Welcome back. In this video, I'll show how to upgrade a small lab machine with a low cost Siemens PLC. Okay, this machine has problem that it will not turn on and there is a alarm sound, and that because of there is no program inside that controller. This controller program is washed out. Okay, so we have contact with the supplier OEM. They told they will not support because they obsolete that machine. We have to buy a new machine. So sense the control system full HMI instead of the display LCD display they provided. We will use the KTP 400 basic HMI and we will use the CPU1212C PLC. Okay, and we will use a SD card that for analog output to VHD, this VHD. Okay, and power supply will install because of they have used the transformer to step down voltage from 230 to 24 volt, and that 24 volt power they have converted into 24 volt DC by using that rectifier. Okay, so guys, we will install that PLC and we'll wiring all the cables. After that we will get back to you again. Okay guys, this is our drawing we have made for upgradation that mixing machine. This power line component, circuit breaker, filter, VHD, motor, that are not changed. This all are the old component. This VHD make 230 means single phase to 3 phase power to that motor. Okay, we have installed just SMPS, this CPU and this 4 TB for making the 24 volt bus. Okay, because this SMPS has 2 terminal for positive supply and 3 terminal for negative, but we need more terminal for given the source. So from this first terminal of this SMPS we have connect the power to this CPU for energize, and from L plus and M from this CPU to output we have connect to HMI to energize HMI. Okay, here important things that why we have choose 1212C DC relay, because see we need to give a command to this VHD to start. Okay, that can be use set point, RPM set point, or the constant speed set point, but we need start command. After that we can use that constant speed 1, or if we use that analog output, but we need that VHD start command, right? So we have connect VHD 24 volt command to that L1 plus. After given start it will give a pulse or constant source that positive is detection to that VHD. Okay, means level power always be there. Okay, but also we need to give a command to solenoid valve, sand solenoid valve, that will open the gate to mix the sand with the cement. Okay, and that power should be different. We have used 1212C DC relay that has 2 separate circuit. So first circuit common 1L plus that has 4 output, and second circuit will be 2 plus common and there are 2 output 0.4 0.5. so from 0.4 we have given the connection to sand solenoid valve, and that common will be coming from that 24 volt bus. And also that VHD has one common analog and one positive for speed feedback and one positive for speed set point. So we have connect 3 core cable. One will connect to common, another will connect to speed feedback, another will connect to speed set point. So we have connect that BSD analog input output common here, and for speed feedback we have connect 0 because this CPU has inbuilt 2 analog input. Okay, so from this 2M we have connect a jumper cable to SB1232 common M, and from the positive terminal we have connect to BSD. Okay, by this way we can give a set point from this SB1232 to BSD. Okay, TI portal, we have already make this program because see, we don't have the manual or principle of operation. Okay, because this machine is damaged. Okay, so we have just talk with the operator, lab operator, and they told us how it's operate. So we have program. So first we have program that they give observation, then we have change. By this way we have make the program, and that is running well now. Okay, this is the program. Okay, first I will show how we have configured this CPU. So we have insert a SBC AQ1 cross 12 bit. Okay, and that is we have taken from that signal board AQ, this one. Okay, we have just drag and drop here. Okay, as it is already there. Okay, it will not take again. Okay, and so if we open by clicking this SB board, it will show the address of that analog output, that is 8081 channel 0. We have used the voltage signal to give the analog set point, means RPM set point to BSD, because that analog input is voltage source 0 to 10 volt. Okay, so we can choose voltage current, but for our BSD we need voltage signal. Okay, so if you click here you can check the IO tag that we have connect the MCB ready signal in 0.0, BSD ready in 0.1, this detection 2, and this in place. This detection signal coming from a proxy that if they place the dish or bowl in the hinge, it will detect. Okay, and after the placing the dish we have a handle. That handle, if they push upward, it will place for operation. Okay, and we have connect the emergency stop signal to I0.4. we have also declared the start signal and BSD run, but that start signal we have not wired because we have used a KTP 400 basic HMI. We can start from there. Okay, and BSD run signal, that also we did not wire because we have taken the analog input, that is actual BSD speed. Okay, motor speed coming from BSD. We just compare that if the signal more than 10 RPM, then it is a running, motor is running. Okay, and we have connect the RPM actual in that first input of that inbuilt analog input, and that one also a voltage signal. Okay, if you go here, we can check analog input 1. There are two analog input, channel 0, that is voltage signal 0 to 10 volt. Okay, that one also 0 to 10 volt, because this analog inbuilt analog input, this only support only voltage signal. Okay, so if you go to that HMI, that we have a root skin that has the selection, program select. So after selecting from this drop down menu, we have to click on the go to button. It will open a new skin, process skin like this. Okay, from here they can start the process if there is no alarm. Okay, if there is a alarm, they have to rectify by clicking the reset. If it is reset, then okay, they can start. If it is not reset, then we have to rectify the fault. Okay, there is a stop button, you can stop anytime. Okay, so here we can see the total process time set, how much the process time and how much it elapsed after given the start command, and speed 1 time, how much it will run, speed 2, and the waiting time in between the speed 1 and 2. Okay, and sand filling time, also the speed set point we can see from here. Okay, so if we go back to that home button, it will again open that root skin. From that root skin we can select the speed. Okay, so if you click that setting button, it will open that setting skin. Okay, from here if I click this button, then it will select that we can run the process, this system, by using constant speed. Means the digital to digital input, digital output, that here this constant speed 1 command and 2 command. If I disconnect this or anyhow, if it is damaged, we can run by this to analog digital output speed, constant speed output command to that BSD. Okay, so that will be select from this constant speed selection. If it is selected, then it will run by the constant speed selection, and that is given parameter in the BSD. Okay, so if I simulate just the HMI, because it will take time if I show all the things PLC program, it will take time, but I will share the program and the drawing. Okay, from here say I can start, stop, reset. Okay, if I go back to that home screen, I can select the another profile of the program. So by this way you can just program your small machine, lab machine. Okay, if your controller is damaged. Okay, so let's download that program and test. We have placed new PLC and wiring also has been done. See, and the HMI program also not download. Okay, and I have installed a select switch just for connection with PLC and HMI, because in this PLC only one port, so to communicate with both PLC and HMI I have installed a select for temporary basis here. Okay, later I will disconnect and connect this red cable to PLC. Okay, let's download. So first we have to check that our PLC and HMI IP address set or not. Otherwise you cannot download the project to HMI or PLC. To check the PLC IP address, you have to go to that online access here. Okay, from here you have to open the LAN driver that you have connect. So Realtek PCI GB family controller, this is my laptop Ethernet driver card. So I will click on the update accessible device. See, we have get two device. One is PLC. See, by this icon I can see it is a PLC, and by this icon I can see it is a HMI. So to set the IP address, I will go to online and diagnosis, and from here, okay, I have to go to function. Here I have to assign the IP address. See, the IP address is now 00. So I'll make it 192.168.0.1. okay, and the subnet marks 255.255.0, and I don't have the router or gateway, so I'll make it assign. Okay, so here accessible device is this, and now I'll set the IP address for HMI. Same way I'll go to online and diagnosis. From here assign IP address. Okay, 192.168.0.2. okay, so 255.255.255 assign IP address. Okay, so IP address set. If I update accessible device and see, you can see both device has the IP address now. So I'll download the HMI project first. To that HMI, just select and download. Okay, I'll set the openet. Okay, this one, and direct. Okay, so I have get the accessible PLC now, or HMI. So I will just download by clicking the load button. Okay, component with the different version are installed on the target. So I'll click on the feed and override download. It is taking some time to download the PLC program for first time. Okay, let's see, this is the first time. Is there any message? No, we don't have the protection, like we didn't set any password for read write. Okay, I'll make it start the program.
for first time. After that, when we will turn on the power, it will automatically on run mode. It will go into run mode. Okay.
Then our time.
ওটা তুলে নেব
এখানে করতেছে স্যার আসতেছে waiting time কত সেকেন্ড এটা 30 সেকেন্ড maybe 60 seconds না 90 বোধ হয় 90 সেকেন্ড 180 তে চালু হবে 60 সেকেন্ড পর
Thank you.